You know that feeling staring at a massive code base just completely overwhelmed? Well, it turns out today's most advanced AI agents feel the same way. We're going to look at a new framework called SWE-Pruner that teaches AI a super important human skill: how to cut through the noise and focus on what actually matters. Okay, so we're at this incredible point where AI agents can do way more than just write a few lines of code. I'm talking about navigating entire repositories, running tests, even fixing real-world bugs. It's a massive, massive leap forward. So, if the AI can do all that, what's the holdup? Why isn't it just our go-to software developer now? Turns out there's this one huge bottleneck that's really holding these powerful agents back. They call it the context wall, and it's exactly what it sounds like. I mean, think about it. Real-world software projects are huge. When an AI tries to swallow all of that code at once, it gets super expensive and incredibly slow. And even worse, all that noise can just lead to confusion. Its attention gets diluted and it starts making mistakes. And get this, a preliminary analysis found something just staggering. 76% of an AI's brain power, its token budget, is spent just reading code. Can you imagine? It's like trying to find one single recipe, but being forced to read an entire cookbook from cover to cover every single time you need it. That's the kind of crazy inefficiency we're talking about here. So, okay, how do we fix this? Well, the big idea here actually comes from watching how human programmers do their jobs. Because we don't read everything, right? We're a lot smarter about it. Yeah, this comparison just hits the nail on the head. A naive AI? It's going to chug through all 10,000 lines of a file every single time. But an experienced human developer? Nah, they skim. They've got a goal, right? Something like find the error handling, and they just strategically scan to find the few lines that matter. That is the exact skill we need to teach these AIs. And that is exactly what SWE-Pruner does. It's a framework built to give AI that human-like superpower of selectively skimming code so it can focus its attention only where it's actually needed. So how does this actually work? Conceptually, you can think of SWE-Pruner as this really smart filter, or maybe like middleware. It sits right between the AI agent and that giant code repository. So when the agent asks to read a file, SWE-Pruner jumps in, intercepts the raw code, and filters it down before it ever overwhelms the AI. The process is actually beautiful in its simplicity. It's just 3 steps. First, the AI states what it's trying to do, which they call a goal hint. Something simple in plain English like, find the user authentication functions. Then a really lightweight neural skimmer uses that hint to go through and score every single line of code for how relevant it is. And finally, only the most relevant, highest scoring lines get passed to the AI. So it gets the gist, the essential info, without all the junk. And hey, a quick shout out to the amazing teams who put this together, the LMSE lab at Shanghai Jiao Tong University and the Douyin group over at ByteDance. Really innovative work. All right, so it's a really clever idea on paper, but does this whole human-inspired approach actually work in the real world? Let's dig into the results from the testing. Okay, first up, let's look at the most obvious impact: token usage. And wow, the difference is just night and day. SWE-Pruner drastically cuts down the total amount of data the AI has to process, and that translates directly to lower costs and way faster performance. And it's not just about reading less, it's about thinking smarter. See, by getting a much more focused context, the AI can solve problems in way fewer steps. It stops making all these redundant exploratory moves because it has a much clearer picture of what it needs to do next. So on this super tough SWE benchmark, the results are pretty stunning. SWE-Pruner slashed the total tokens used by an average of 40.5%. Just think about that. For any company using these tools, that's like cutting your AI cloud bill almost in half. That is a massive, massive efficiency gain. But here's the kicker. This is what makes it a real breakthrough. All of that incredible efficiency comes with less than a 1% drop in the task's success rate. So it's getting the job done just as well, but with almost half the effort. It's all signal and basically no noise. And if you look at its peak performance, it's even more mind-blowing. On certain specific tasks, SWE-Pruner managed a compression ratio of nearly 15:1. It was delivering only the absolute most critical sliver of information to the AI. This quote from the research paper really just sums it all up perfectly. They say that by filtering out the redundant info, the AI can locate issues more precisely and make more decisive decisions. It's simple, right? Better input leads to better output. Okay, so let's zoom out for a second. Why is a tool like this such a big deal? I mean, why is it more than just some clever optimization? What does this really mean for the future of AI and software development? So here are the key takeaways. First, this makes AI coding way cheaper and faster. That's a huge one. Second, the agents themselves become better problem solvers. They're more efficient. And that makes them way more practical as actual collaborators you could use day to day. But here is the most important point, I think. The real genius here isn't just about removing text, it's about adding focus. It's about making the AI smarter, not just making the context smaller. And that brings us to one final, pretty mind-bending thought. We just saw a framework that teaches an AI to read code with the selective focus of a human expert. So the natural next question is, how long until it can truly reason about that code with the same kind of intuition and insight? Because that's the future this kind of work is pointing us toward.
Anthropic just gave its AI, Claude, a massive upgrade. And this is a big one. We're moving beyond the idea of an AI that just chats with you. We're now stepping into a world where an AI can actually roll up its sleeves and do the work with you, right inside the apps you use every single day.
So, what does this new superpower actually look like? Well, here's how we're going to break it all down. First, we'll cover what this new feature is all about, then we'll look at how it actually works and how it stacks up against the competition. After that, we'll get into the truly game-changing stuff, the future of agentic AI, and finally, we'll talk about why all this new power means we really need to be careful.
Okay, so here's the headline. Claude is officially evolving from just a conversational partner into an active teammate. This is a really fundamental shift in what we should expect from our AI assistants.
I mean, we've all been there, right? You get a fantastic idea from a chatbot, but then you've got to switch over to another window and actually do all the manual work yourself. What Anthropic is doing here is basically getting rid of that step. It's all about turning the conversation directly into action.
So how does Claude actually plug into your workflow? Let's pop the hood and get into the nuts and bolts of this new feature and see how it connects to the tools you're probably already using. Now, this list of launch partners is super telling. It's not just some random collection of apps, right? It's a very deliberate group of workplace tools. You've got Slack for team chat, Canva and Figma for design, Box for file storage. This screams a clear focus on the enterprise world right out of the gate.
So who gets to play with these new toys? Well, for now, this is a feature for paying customers. If you're on a Pro, Max, Team, or Enterprise plan, you're good to go. But this isn't available for free users right now, which really shows you just how valuable Anthropic thinks this new capability is.
And this quote from Anthropic's announcement really gets to the heart of their whole philosophy. Look, they are not trying to replace amazing tools like Figma or Salesforce. Nope, the goal is to combine the awesome visual interfaces of those apps with Claude's brain power. The result? A workflow that's way faster and more powerful than either one could be on its own.
Of course, a big move like this doesn't happen in a vacuum. Anthropic is stepping into an arena where others are already playing. So how does this all compare to the competition? Specifically OpenAI.
This gives us a really clear side-by-side. You can see OpenAI's system launched a bit earlier and has a wider net of third-party tools. Anthropic is just launching now with that tight focus on the workplace. But the most important detail here, the real strategic piece of the puzzle, is that last line. Both companies are building on a shared foundation.
And that foundation is called the Model Context Protocol, or MCP. The easiest way to think about it is like a universal translator or a standard power outlet. It lets all sorts of different AIs connect to apps in a standardized way. Now, this is more than just a technical detail. It's a huge strategic move. By working together on an open standard, they're helping create a whole ecosystem where developers can build tools that work for multiple AIs, not just one. It's a big step towards preventing any single company from creating a walled garden.
Okay, now we get to the really mind-bending part. Because these individual app integrations, they're just the first step. They're the building blocks. The real vision here is something much, much bigger. Something called an agentic system. I mean, letting Claude send a Slack message for you is cool. It's a useful shortcut, for sure. But what's coming next isn't just about making one little task easier. It's about automating entire complex workflows. We're talking about a completely different level of autonomy and capability here.
So an agentic system is basically an AI that you don't have to micromanage. You can give it a high-level goal, and it will figure out all the little steps it needs to take to get there, jumping between different tools as needed. It's less of a tool you command and way more of an autonomous agent you collaborate with, like a true AI coworker.
And Anthropic already has a name for this vision: co-work. This is the end game. Pretty soon, you'll be able to say something like, "Hey, cowork, analyze the latest sales data from our company's box folder and then use what you find to update the Q3 marketing graphic in Figma." And it just does it. The AI connects the dots, switches between the apps, and handles the whole project.
But of course, giving an AI this much access and autonomy, that's a massive leap. It has incredible potential, but it also comes with some pretty significant risks. And to their credit, Anthropic is being super upfront about the need to be careful here.
And look, this is a direct quote from their own safety documents. They are explicitly telling users, hey, be thoughtful about the permissions you grant. Giving an AI access to sensitive financial info or personal records is a really serious step, and they recommend sandboxing its access, like creating a dedicated folder for it to work in, instead of just handing over the keys to everything.
So the key safety tips are really clear. First, keep a close eye on what the AI is actually doing. Second, only give it access to what it absolutely needs to do its job, nothing more. Third, steer clear of super-sensitive data. And finally, try to contain its workspace. It's all about being responsible and building the guardrails before we go full throttle.
And those guardrails are absolutely essential, because this tech is fundamentally changing the relationship we have with AI. We're moving from a world where it's a passive tool we direct to one where it's an active teammate that works right alongside us. It's a pretty incredible shift with huge implications. The technology is almost here, but the real question is, are we ready for it?
Welcome to The Explainer. Today, we're not just looking at a piece of research. Nope, we are cracking a case. The mystery, a super powerful open-source AI that was supposed to learn all these complex tasks, but instead it just completely broke down during training. This, my friends, is an AI detective story.
So first, let's get our heads around the dream here. The whole goal was to use this technique called agentic reinforcement learning. Now, this isn't about training an AI to just, answer questions. It's about building a true digital assistant, one that can actually do things for you. We're talking planning a project, writing and testing code, and taking a whole bunch of steps to solve a complex problem all on its own. A team of engineers at LinkedIn, they set out to train the powerful open-source GPT-OSS model for these exact kinds of tasks. But the moment they kick things off, bam! They hit a wall. The model wasn't learning. It was failing. And I mean, it was failing spectacularly. All right, here's our case file. We're going to follow this investigation step by step, right from the initial crime scene all the way to the final verdict. Okay, so the first stage of any investigation, you got to examine the crime scene. And in the world of AI training, the crime scene is all in the data, the logs, and the performance metrics. The team had some pretty clear expectations. As the AI trained, its performance, which in their world they call a reward, it should have been steadily climbing up and up. The training process itself should have been nice and stable. But the reality was the complete opposite. The reward totally flatlined, and the entire training process was just wildly unstable. Nothing was working. And here it is, the first major clue. This chart shows the model's gradients. You can just think of them as learning signals. Now, in a healthy model, that first bar, those signals are low, they're stable. But for GPT-OSS, whoa, they were completely off the charts. This is what's known as exploding gradients. It's like the model is trying to learn so hard and so fast that its internal math just kind of breaks. This was the smoking gun. So, let's move on to the first suspect and see how the team chased down an early, but as it turns out, a totally misleading clue. The team's first suspect was a violation of a core rule in their training method, which is called PPO. Think of it this way. PPO demands that the AI learns only from its most recent actions, not from outdated experiences. For all the math to work out, there has to be a perfect one-to-one match, which proves the AI is learning from its current self. And here's what they found. GPT-OSS uses something called a mixture of experts architecture. It's like having a whole team of different specialists inside the AI. The problem was, because of these tiny random fluctuations, the AI would sometimes send the exact same problem to a different specialist on a second try. And that broke the perfect one-to-one match. It really looked like the smoking gun. So they applied a patch. It was a diagnostic test to force that ratio back to a perfect 1 and see if it fixed the problem. But it didn't. The gradient still exploded, the reward was still flatlined. This suspect was a dead end. The real culprit was still at large. After hitting that dead end, the team knew they had to dig much, much deeper. And this is where they moved from a simple inconsistency to a really fundamental flaw, leading to the story's big aha moment. Their new hypothesis was something called a training-inference mismatch. In simple terms, this means the rules the AI was following during school, during training, were different from the rules it used on its final exam, during inference. It was basically being taught one thing, but then tested on another. So the investigation led them to this really subtle but critical feature called attention sinks. You can think of these as a none-of-the-above option for the AI's attention. So instead of being forced to focus on some word and a really long text, it can choose to focus on this virtual sync, which helps keep it stable and focused. And this was the core of the problem. The model was essentially learning with a different brain than the one it was being tested with. The code used for training didn't support attention sinks, but the code for actually running the model did. This fundamental mismatch was the real reason the whole thing was collapsing. Now, solving this was not easy. They couldn't just go and download a patch. They had to perform some pretty complex software surgery, taking a newer version of the code, borrowing a piece from a completely different project, and then custom building the missing part themselves, that crucial piece of code that actually lets the model learn from its mistakes. So let's look at the payoff, right? To really isolate the problem, they tested it on a simple math task. And before the fix, the model's performance, its reward, it barely improved at all over time. It was just struggling to learn even the basic stuff.
But after implementing attention sync support, just look at that. The reward shoots way up, the learning is fast, it's stable, and it converges beautifully. This was the proof. They had finally caught the real culprit behind all the training failures.
Now, with the main case solved, the team wasn't done just yet. They also had to tackle a secondary mystery, a memory bug that was just as catastrophic, a case we can call the out-of-memory heist. See, during training, they kept hitting these crashes, and the logs revealed why. A bug was trying to allocate 180 gigabytes of memory on a GPU that only had about 140 available. I mean, it's an impossible request. No wonder it was crashing the system over and over again. They solved this memory heist with two really clever optimizations. First, they patched that mixture of experts' code to stop it from inefficiently duplicating massive amounts of data. And second, they implemented a technique called sequence parallelism, which cleverly splits up these long conversations across multiple GPUs, so no single one gets overwhelmed. So, after all this, what's the big takeaway from this entire investigation? What does solving this case really mean for the rest of us? Well, the team's meticulous work resulted in 3 major engineering contributions. They restored the integrity of their training method, they custom-built that missing attention sync support, and they solved critical memory bottlenecks. And altogether, these fixes transformed GPT-OSS into a viable, powerful backbone for agentic AI. And that really is the final verdict. This whole case shows that progress in AI isn't just about big, flashy new theories. It's often about the hard, detailed, and persistent engineering detective work that's required to make those theories actually work in the real world. And this whole case leaves us with one final provocative thought. As these AI models become almost unimaginably complex, you have to wonder, how many more of these deep, hidden bugs are just lurking beneath the surface, waiting for the next team of detectives to uncover them?
Okay, so let's just jump right in. We are absolutely swimming in data, right? But here's the dirty secret. Most of it is, well, it's a total mess. For what feels like forever, getting that data ready for anything useful has been the slow, painful, and super expensive manual job. But that's all starting to change. In this explainer, we're going to dig into how a brand new kind of AI is finally tackling this massive, trillion-dollar data problem.
And, when I say trillion-dollar problem, I'm not just throwing around big numbers for fun. Just look at this, 30%. The estimates say that messy, inefficient data can cost a company up to 30% of its revenue. I mean, that is a staggering amount of money just gone, wasted. And it's all because the raw information that businesses are gathering is basically useless right out of the box.
So what gives? What's the holdup? I mean, why has this been such a tough nut to crack for so long? It's not like people haven't been trying to fix it. The real problem, well, it's baked right into the data itself.
All right, so the source material really breaks this down into 3 big buckets of headaches. First up, you've got your basic consistency and quality issues. We're talking typos, empty cells, and like 12 different ways to write the same date. Ugh. Second, there's the whole isolation problem. Your data is trapped in all these separate systems, each with its own format, and they just don't talk to each other. And finally, and this is a big one, you've got semantic limitations. The data has no context. It's just a bunch of numbers and words with nothing to explain what they actually mean.
So to deal with all this, we are in the middle of a massive shift in thinking, a real paradigm shift. We're throwing out the old, clunky, rigid ways of doing things and stepping into a totally new era of intelligent data handling. It's a move from what we call brittle rules to actual reasoning.
And this slide, wow, it really lays out the before and after perfectly. The old way, it was all about brute force. You had to have experts writing these super complicated rules and scripts. And those rules were brittle, meaning if anything changed even a little bit, they just break. They had zero understanding of what the data actually meant. But the new way, the one powered by large language models, or LLMs, it's a total game changer. Now you use simple, plain English instructions. The AI gets the meaning. It can apply what it learns to different kinds of problems, and it already knows so much that you don't need to spoon-feed it nearly as much labeled data.
All right, so let's look at how this new approach works in the real world. First up, AI-powered data cleaning. This is where we start turning that chaos into some real consistency.
So what is data cleaning really? It's pretty simple. It's the job of fixing all those errors and messy bits we were just talking about. It's all about taking that raw, unreliable junk and turning it into something you can actually trust, something you'd be willing to use for important stuff like business analytics or, training another AI.
And here we go. This is a perfect and frankly super annoying example that anyone who's worked with data will recognize. Dates. They're in every format imaginable. In the old days, the developer would have to write this nightmare of code, we're talking complex pattern matching, just to handle every single possible way a date could be written. Now, you just tell the LLM what you want. That's it.
And the process itself is it's so simple. It almost feels like cheating. Step 1, you just say what you want in plain English, something like, hey, convert all these dates to the year, month, day format. Step 2, the LLM actually understands the intent behind your words. And step 3, boom, the data is transformed automatically. No more custom writing fragile code for every little thing.
Okay, but cleaning the data is really just step 1. It's just the beginning. The real magic happens when you start connecting and enriching it, when you start finding those hidden relationships and adding all that crucial context. And that brings us to the next big piece of the puzzle, data integration. Think about it. In almost any company, data is everywhere. It's scattered across tons of different systems. So integration is the massive challenge of hunting down all the related pieces of information and stitching them together into one single coherent picture. Here's a fantastic, simple example. One system, maybe your sales database, says iPhone 13. Another one, your inventory, says Apple iPhone 13. To an old rule-based system, those are two completely different things. But an LLM, it understands the meaning. It knows those two labels are pointing to the exact same thing in the real world. This is what's called entity matching, and it is absolutely fundamental if you want to get a real, honest picture of your business.
All right, so your data is clean. It's integrated. Now you can get to the really good part, enriching it. Think of this as moving beyond just tidying up your house. Now you're decorating. You're adding new layers of context and insight that make the data not just a little bit better, but exponentially more valuable.
Just look at this. On one side, you've got a raw table of numbers. I mean, on its own, that's pretty meaningless, right? It's just noise. But you feed that into an LLM, and out comes what we call a semantic profile, a summary a human can actually read and understand. It tells you, hey, this is enterprise sales data, and the average sale is about 6.6K. It literally turns raw, meaningless numbers into actual, usable knowledge. And this is where things start to feel like science fiction. We're moving past using AI for just one-off tasks. The next frontier is something called agent-based orchestration. You can think of it like this. A central LLM agent acts as the project manager. It understands the whole goal. And then it intelligently plans and delegates all the little jobs, cleaning, matching, labeling, to other specialized AI tools. We're talking about full-on, end-to-end automation.
Okay, so as awesome and exciting as all this sounds, let's pump the brakes just a little. We're not living in some data paradise just yet. This tech is incredibly powerful for sure, but there are still some pretty big challenges ahead.
So what are we up against? Well, first, there's the cost. It's not cheap. Running these giant models on massive corporate datasets is still prohibitively expensive for many. Second, you have the ever-present risk of hallucinations. You know, when the AI just confidently makes stuff up. That's a huge problem for trust. Then you have to worry about reliability. Can you really count on these complex agent systems to work perfectly every single time? And finally, how do we even measure success? We need better, scalable ways to check their work and make sure they're actually doing the job right.
And all of this leads to one final, and I think really crucial question. This technology is getting better and better at automating all the tedious, boring, time-sucking parts of working with data. So as the AI takes over all the grunt work, what's left for us? What becomes the uniquely human skill in this new world of data?